Okay, now we have completed this modeling part of this project. Now, the next step is to create the drawing, detailed drawings. And also we're going to add tolerancing to this drawing, and then you will learn about the Autodesk Inventor's tolerancing feature. So let's begin using our new template that we have, our class template. And always I start from the create file from the list of the template, and make sure if you're not seeing that, you be on the English folder and you will see Engineering 18 and create. And you add the information. In this case, I have given you the copies. There's a posted copy of this final finished project here. If you notice that I have a scale already. In case you don't know, you can always assign 1 to 1 or 1 to 2, then come back and change. This is the 2/3. I use 2/3 because 1 to 2 is too small. Again, 1 to 1 is too big. So let's begin this one again with the scale 2/3. I can type in 2 colon 3. That's more typical mechanical drawing. We show it like that. And even though mathematically it's the same thing, you can say 2/3 or 2 colon 3 or 2 equal 3. And again, remember always the left number is your paper and the right one is actual piece. Now, enter the project number. I believe the canvas number should be here, 16.1. You can check that with the canvas. And then enter your last name or first name, your full name. And then, okay. We're going to start with the base. In this case, base should come up right because we did use, we have not saved our model. That's right. We need to go back to, that's always, is a good warning there. We need to go back to create the model on this one before we save them. I have right now part 3, but I have not given a name. So we will say save and give a name. I'm going to use their proper name for this using the title block or part name, pivot log. This way, when you save on your drawing, it would take that name as a title automatically. So now we have back to drawing and then start the base. Now you notice that came in with the default setting for Inventor things. That's 1 to 2 is a good size, but we are saying no, we don't want that. We want to change. Remember, what you type here doesn't necessarily change the scale. It's just the information. What defines the scale is this portion here, where we type 2/3, which is not exactly part of the list. So we need to add that customized scale because it's not a common scale what we're using for our class purpose. So 2/3. That gives us better view. And of course, move to the right location. This is the front view, so it goes to the front. Project. Also, we need to right side view here, probably. That's a good idea. And then right click and create. Okay, now we can do other necessary changes to these views. If we want to have it shaded, we can go back to change under the edit view. And I'm going to change that scale to 1 to 2 for this isometric. Remember, isometric doesn't have to be necessarily following these scales. However, these have to be the same scale, which automatically does when you change the base view. So here we are going to select that shaded view. Okay, now the question is adding the proper dimension. I'm going to just show you how to do the tolerancing here. But of course, once you switch back to the annotation and place your center marks first. And there are some more center lines for all the views that you need to place them. We will come back to change some of the settings and other little details that we have discussed before. So I'm just going to go quickly on this one to start with this tolerancing feature. So let's go back to this assignment sheet. There are a few things here that you need to know on this assignment. If you notice on your textbook, they give you some information that using that table, we will define our tolerancing. Also, we have a table that I have posted for you on Canvas, and this is from your textbook under the Appendix A. You have all this information. That it shows the relationship between hole and shaft, how they fit together, which we will discuss that more in chapter 9 topics. You notice that all these numbers based on thousandths of an inch. I tell you on this top portion here that all the numbers in thousandths of an inch. So that's what you read. You need to divide by thousands. The reason for that, of course, that would be so many decimal points and the column would be too wide to show all these. So what they have done, they have multiplied every number by 1,000, and then we, as a user, we will use fraction number 1 over 1,000. So multiply 1 over 1,000 or divide by 1,000. So here, like for example, you see the 0.25. Of course, tolerance cannot be 0.25 for this small hole. So it has to be divided by 1,000. So you would move to 3 zeros to the left. So that's how you would do these. Okay, so they give you information on your textbook regarding this hole for 0.5 using the RC2 for diameter 1 basic hole system using RC5. So RC2 for 0.5 hole. Let's go back to select that from diameter of 0.5, which falls between 0.4 and 0.7, that's 0.5. And then on the column the RC2, we read these two numbers. Okay, just a little concentrate on these two numbers here. If I can enlarge that a little bit. Okay. Now, we have 0.4, 0.5. This is the range for the size, the diameter of the hole, which in our cases are 0.5 falls here, and RC2 is the type of the limit. These are, again, defined as a different design, requires different fit. Some of them are loose, some of them are just a standard, normal, general purpose. Some of them are for tighter tolerancing, depends on application that we use for mating parts. Okay, now back to this number. How do we going to use that? So 0.4 positive value. So that means we're going to divide that by thousands. So it would be 0.0004, 3 zeros, right? And then you have lower value, which is 0. There's no change on the lower value. So let's go back to adding that. Adding these dimensions on the inventor, under the annotate, we have this feature, which is the hole and thread. We will select that and point to this hole and move to some, again, notice that the angle I'm using again, using some of those basic dimension rules. So now we have this dimension done without any tolerancing. So let's just concentrate on that and see what this automatically did for us. Remember, I did not use dimension here. I used this hole and thread because recognize that we have used the hole feature automatically gives us that. If I use the dimension, then I had to type this myself using the symbols, using this symbol and this. So this is much faster. Now, we have to make some changes to that because we want to display the tolerancing. If you refer to your handout sheet that you see, I have given you the solution for that. So it's 0.5504, 0.5, and then after that 2 zeros and then 4. And remember where this 4 comes from that table that you adds to the positive value, and the negative value, the lower portion of this tolerancing, it's 0.5, nothing changed on that one. So what this means that this can be increased only in one direction, but cannot be smaller than 0.5, but can be as large as 0.5004. So how do we display that? We will go back to, also here, notice that shows 0.875. And if you notice on our drawing, it shows 0.88 because I have only 2 decimal places. So let's do those changes. Now, when double click on that, this opens a new dialog box for us and shows all this information. The first thing you need to do that you need to select first we need to make some changes to this. So what we need to do first, click on this little pencil here that shows plus or minus, precision and tolerance. You notice that precision and tolerance. Click on that little tab, and this opens another box here. The key things are here. All are gray. All these numbers are gray, so I cannot change anything unless I uncheck this box that says use global precision. So by checking this program to use your global tolerance, it means something goes in the note saying all dimensions has a certain tolerance. But here we are using local tolerance, not global tolerance. So we're going to uncheck this box. As soon as you uncheck that box, these are now we can make some changes to that. So we need to expand this a little bit. So you don't see all the values here until you click on this little arrows and you see more information. We are going to change this primary tolerance as you see here, to 3 decimal places. That's one thing we need to do. By doing that, that would not show 0.88, so that would show us pretty accurate value, 0.875. And now we're going to check this box here for tolerancing for whole, not counterbore, for whole. See, this is the whole, the first one. We're selecting that. And then also we're going to use this method. Remember, there are different methods of the tolerancing, which we will discuss in chapter 9. And then here we have limits stacked. This is more common because it already has done the math. We don't have to do plus or minus, then add ourselves. So this is limits and stacked. And then precision, we will have here probably 4 places. We need to have like 0.000. Let's try 4 places. And that's alternate precision you don't have to worry about. And now we have this. And what you need to do, the upper value, I'm going to add 4 here. Remember that 4 we got from the table? Remember this 4 we had for RC2, this number here. This is the one we are using, divided by 1,000 and adding to this value here for the upper. So lower doesn't change, it's 0. So if I do that, hopefully everything should be. Now let's just OK to that and see what happened here on the changes. Notice that everything is calculated for us. All I had to do some changes on the settings and change that. So this is what I was going to show you that. And then, of course, other one would be the same. So this is something new. Rest of the dimension, as you see on this handout sheet, already provided for you, the solution. So try to come up with the same format. We have discussed these before, all this type of dimension, the format techniques. And also notice that we have a reference dimension here. That means the depth we have here is in the parentheses, because we already know that this is 3 inches from here to here, because this is 1.5 radius. So it's not necessary for manufacturing, but is something for inspection, packaging, and so forth. So that's what we call reference, and is inside the parentheses. So with that, I'm going to end this video, and then you can continue finishing that. So that concludes this video on tolerancing use for Inventor.